Okay, all right. Okay, so let's again start. So today we'll discuss this very important, this is cryptography. So I would like you to be extremely attentive in the class, right? Okay, so we are here in the course. We completed some very important fundamentals that these are the basis of the course, like security principles. All we want to achieve is security principles. Okay. And then we have studied CIA model, where the three aspects that we deal with now onwards through cryptography is confidentiality, integrity, authenticity, and also availability, and some other aspects like now. Okay. All right. So let's start. So let's revise our CIA model because it's very important. We study cryptography because the aim of the cryptography is achieve confidential integrity, authentication, and of course increase the availability. Okay, mainly three: confidentiality, integrity, and authentication, and of course aspect of authentication and reputation. So confidentiality is concealment of information, sending message to B, and then this message that goes over internet. Now internet is a leaky medium, is non secure medium. Okay, all right. So this message that goes from A to B should not be available to or read by anybody. That we call eavesdropping. In between there can be Eve, who should not see these messages, or it's also called packet sniffing or illegal copying and all that, right? So this property is called confidentiality. Second is integrity, wherein message sent by A to B should not be intercept a malicious person and should not change this. Or okay, this message that comes from say M from A, which is meant to go to B, should not be intercepted by mallory and should not be changed to something like M dash. Okay, so if this is not done, nobody is able to change the content, then we say integrity. So integrity is authorized changes, and authenticity means that knowing whom you're talking to. Here B thinks that she is talking to A, but in fact it's in between M who's talking to B. It means that this communication, although B thinks that she's talking to A, is not, while in fact in actual she's talking to M. So this is called non-authentic. So authentic is where B knows actually she is talking to A. All right. Availability is that when talking to B, it should actually reach in between, or all the resources in between, like for example, should be available and do the job. Nobody should block this, right? So availability is nothing but so we say availability is ability to use information or resources. Like we have disruption of internet communication, then we say it's not available. These are the important properties. Now we'll have to see how to achieve this through cryptography. We have already started using like friends and enemies in security world. So we have some of the characters that we'll be using, like Alice and Bob. These are the main characters. Alice sends message to Bob. Okay, and we have characters. So these are two main characters. Okay, and then we have other characters like Carol, Dave, etc., who can party later, but we will not discuss Carol and Dave. Then we have important character called Eve. Here is Eve, and she represents eavesdropper, right? Now, eavesdropper is just not so malicious, but her intent is just to read what's happening. She is just interested in eavesdropping. Okay, and then there is a character called Mallory. As M stands for is malicious. Okay, all right. The Mallory can change the message, right? Is a manipulator or malicious and modify. So Eve can only read while Mallory can change it also, right? Well, Alice sends a message to Bob and say, I love you. Mallory should not change if Mallory should not receive it, and she should not be able to hit you or whatever, right? Okay, so these are the main characters. But Mallory is malicious person. Her intent is to not only read but also, all right. Okay. Some authors also use word Trudy. Mallory, instead of Mallory, we can use Trudy. Okay, or we can Trudy can do both eavesdropping and all right. So these are the main characters. All right. Now, in actual practice, who are these people? We can see it be any program, right? Okay. So these points we already discussed. If Alice wants to send message to Bob, however, Eve is going to stop on the communication channel. Now the challenge is in this cryptography is that Alice should be able to send message to Bob without Eve learning about what this message contains, or without allowing Eve to eavesdrop. Even if Eve is able to receive the message, but she should not be able to see what it contains, right? Okay, another scenario is Bob wants to send a message to Alice. When he is passing through Mallory, assume that it's passing through Mallory, Mallory should not be able to tamper with the message or change the message. All right. So we are going to use these characters, and in actual practice, Bob and Alice can be anybody, right? It can be in client server model, it could be a client, could be Alice, and Bob server could be, okay. So you can have your, for example, your browser client is there, like you use whatever, right? And any browser that, okay, and then message goes to a server and server responds with HTTP server. Server here is considered as Bob. It's a client. In between there may be some malicious program or routers in between, routers containing some malicious program, could be Mallory or Eve. Okay, it could be DNS server, it could be route exchanging updates, or it could actually be real life Bobs and Alices. Okay, all right. What a bad guy can do. Our discussion is mainly over because of, so between two entities is sender and receiver. Okay, is passing through internet, like our communication is passing through internet. Okay, this communication could include bank transactions, right? So what do we want? When nobody should see in between what I am sending or what sender is sending, like nobody should be able to eavesdrop. I mean, maybe I am sending $1 million, but in between should not know that I'm sending $1 million, because I don't want that anybody to know about it. Right? Impersonation, nobody should be able to impersonate somebody else. For example, this is receiver and I'm the sender, or actually it should go from me. Enemy should not impersonate as me as or as a sender. Okay, so that's not allowed. So it's basically using the fake source address. Like you can always impersonate when you send a letter, normal postcard kind of letter or physical letter, then you can impersonate name and somebody's name, but still it will go like. And same thing happens in IP packet. IP packet has apart from message, importantly source address and destination address. Now source address, instead of putting your IP, you can always put somebody else's IP, and nobody is going to check that, right? Okay, so impersonation should also be, you should be able to know that when when you're creating absolutely secure system, then you should not allow impersonation, but it's extremely difficult task in internet. Then hijacking, taking action by reviewing sender receiver, inserting himself in place. And fourth is denial of service. Denial of service is, for example, there is a server, banking server, and then you want that server should not be available. You are a malicious person assuming, and you can create thousands of bot or millions of bot, and they will just ping this or send a message to this server, and then this server will continuously answer these messages and will not be available to anybody. Okay, all right. These are the things a bad guy can do, and through cryptography we should protect it, or somehow make sure these things are avoided or not allowed. Okay, we want to achieve through cryptography, we want to have some kind of guarantees, because when I am doing a bank transaction, I transaction to be seen by somebody or altered by somebody, and bank should know transaction, nobody else is doing the transaction. Okay, so I want the following properties: confidentiality, integrity, authentication, availability, and non-replication. All these can discuss in brief in previous. So essentially we want to achieve secure communication over insecure channel, and internet is, and then your Wi-Fi channel is also pure plain vanilla Wi-Fi channel is also insecure. Okay, and we want that security. Then security means that, remember the CIA model: confidentiality, integrity, authentication, availability, and one aspect, mainly CIA. Okay, all right, so we want to achieve this. Now for that we use cryptography, and the common language that we are going to use, apart from Alice and Bob, and in between we have these characters like 2D or Eve, Mallory, etc. Okay, these are the main characters we already discussed. And next thing is that Alice is sending something in plain text, like something that we write in English, for example, or some digits or numbers, and there is an encryption algorithm, and then Alice is using a key called KA to encrypt this message, and what we get is ciphertext. Okay, ciphertext goes to Bob. Bob uses this decryption algorithm using key KB, and what he gets is plain text which Alice has sent. Okay, in between is intercepted by Mallory. She should not be able to read it or change it. Okay, she should read the plain text. She may text, but she will not be able to understand anything out of it because it is ciphertext. All right. Important is that you said encryption algorithm, decryption algorithm, and also two other, which is key, KA and KB. Okay, got it? Any question up to this point? Okay. There are only methods of doing this encryption. Okay, first is called symmetric key encryption. Some is called asymmetric key encryption. Okay. Symmetric key encryption, sender and receiver have the same key, exactly same key. Okay, and asymmetric key encryption, Alice has two keys. Bob also has two keys. First key is private key. So Alice is private key, which only Alice knows. And second is public key, which everyone knows. Okay. Similarly, Bob has private key and public key. Now, public key, both private key and public key are created by Alice. Okay. And Alice sends somehow, or Bob, and it doesn't matter, send the same key. Oh, sorry, I'm so sorry here. I'm sorry, I was talking about symmetric. In asymmetric key, Alice is.
Why speaking in Telugu?
Yeah. Pardon? Who is this? Why speaking in Telugu or something? Who said that? Can you mute yourself if you're not interested in the class? Or please, you can drop from the course if you. If you have any questions, please ask me. Unmute yourself and ask, but don't just make it fun. Better you drop from the class, the person who has commented this. This plain text also can be in Telugu, Tamil, Malayalam, or doesn't matter. Other end will be other text. Encryption algorithm has nothing to do because encryption algorithm assumes the plain. You have done CS, anything about CS, you'll know whatever you are doing, whether I am typing in English or Tamil, Telugu, whatever, is finally converted in zeros and ones. This encryption algorithm is interested in sequence of zeros and ones. That's it. Everything inside computer is zeros and ones, nothing else. The encryption algorithm has sequence of zeros and ones, whether you're using plain text or whatever. Is plain text is coded in terms of zeros and ones to ASCII or what. Okay, so input to that is always zeros and ones. But in this example, we see plain text. It could be input to any machine is okay. Okay, the question I'm asking you from the same guy who's asked this question, or maybe just comment. Are you using cryptography in any of your gadgets or application that you use? Anybody?
So maybe WhatsApp has end-to-end encryption.
Yeah, is very good. WhatsApp advertise it, right? This end-to-end encrypted. What else? We are using WebEx here. Is it encrypted or not? It is also encrypted. Okay. Do you think Chandrayaan 3, we all that right? Lovely landing of lander. So does it contain cryptography? Does it use? Yes. Otherwise, any would have hijacked the whole program. The communication that's happening from Space Center here in Bangalore to over, is it encrypted or not? Of course, going through some. Is it encrypted? Of course, yes. Otherwise, there are enough channels. South Koreans who can disrupt the whole thing. Okay. Everything, almost all apps that you use intern cryptography, like ATM machines. ATM is where you withdraw cash, mobile communication, all are encrypted. 3G, 4G, 5G. Wi-Fi communication, you use it in order to secure WPA. How about browsing? When you use something called HTTPS, then it means that it is encrypted. Email communication, PGP or SMI, both are secure emails. Password storage inside server, yes, is encrypted. Hash, this is one of the techniques, right? Electronic currency, credit card, debit card, Bitcoin transactions, all are encrypted. In fact, when you your account statement of bank, that's also encrypted. Cable TV, I mean, now we have Netflix, right? Is it encrypted or not? The communication that comes from Netflix server to your mobile, is it encrypted? Of course, yes. I mean, like you buy DVD or Blu-ray, now of course it is DVD. Okay, of course now not many people buy DVD. Can you copy one DVD to another DVD until unless you have bought pirated one? You cannot. Okay, how about blockchain or crypto, Bitcoin? What is Bitcoin? Bitcoin is totally based on cryptography. When you use word crypto today, it means are you using cryptocurrency? That's the one we use, right? It's nothing but use of crypto. We'll study that at the end of this course. And lot others like VPN, virtual private network, SSL or IPsec protocol, both we'll study. PGP we already done, DRM, digital rights management, iPhone or whatever mobile you are using, your mobile phone bills and so on and so forth, right? All contain. Now this is HTTP. HTTP with security, TLS. Okay. What do we do? If we send our message in plain without encryption, anybody in between can read it. When you're doing this section, say for example, Amazon.com, you are going to use HTTPS. So how does it work then? First thing is that they want to establish a secure channel from A to B, or from this person to this machine or server at the back end. So everything this person is sending must be encrypted, and everything must be decrypted using the same key. Okay. Now this key, how you are going to transfer this key from A to B, from this client to server or server to client, whatever, is called key exchange program. Now, this key exchange program is done using hash function, digital signature, and public key encryption. So in order to do a symmetric encryption, we use public key encryption, which is nothing but asymmetric key encryption. Okay, we'll study this later. Don't worry if you don't understand it now. Okay, all right. Okay. History of cryptography is almost 2,500 years old. There is always a battle between code makers and code breakers. It means that between the people who design crypto and people who want to break crypto. Now, of course, it's driven by communication and computation. For crypto, you are not going to use hand for encrypting something, right? So, is through computation and driven by communication because over internet. All right. Now, when I'm talking here and you are listening, there should be minimum delay. Okay, we'll come to, of course, this later. So computation has to be fast. So encryption algorithm must be efficient. Otherwise, none of us will use it, right? It has to be fast. One requirement. All right. So you can read about this. Now, of course, we started 1850 onwards, and now we are in modern era where we're using internet. India has a lot of role to play in this one. If you read this, Vatsayana, the text, famous text, talks about secret writing. How can you know, if person A wants to send a message to person B, then what should be the way? How do you actually do encryption? Okay, so Vatsayana came out with technique. It's available in internet, right? You can read about it. Now, cryptography is a full course normally taught in later semester, usually taught by maths profs, you know, or your algo profs or theoretical computer science prof, right? Or theoretical, yeah, PCS profs. Sit on all that, right? Because we will spend a lot of time, then we'll not be able to discuss networking, etc. Right? So our focus is largely on system side or application of crypto. Of course, we will study concepts, but we will not get into too much of mathematics. All right. So this is a field of cryptography, cryptology, and then we have we can divide into two parts. One is called cryptography, and second is called cryptanalysis. Cryptography is about using key encryption, which is symmetric ciphers. Symmetric encryption, we also call it public key. Okay, we'll use this name interchangeably. Okay, and then we also have protocols. Okay, we study HTTPS, and then within symmetric ciphers we have block ciphers and we have stream ciphers. Block ciphers essentially means we take a block of data and then encrypt this into another block. The stream cipher is something that we are using now. There's a continuous stream of bits that are coming from here to you, or from Netflix to you, and then how do we get very fast speed where a stream of data is coming? So this is the classification. Okay, so we'll cover this part. Okay, we're not interested in cryptanalysis. So let it your theoretical computer science professors teach you if you happen to take next level course. Okay, this we have already done. Okay, cryptanalysis is largely about analyzing, etc., and it's basically used for data. All right. These terms we have already discussed: plain text, ciphertext, key, encryption, decryption, and cipher. Any question? Cipher is nothing but algorithm to encrypt and decrypt. Ciphertext is the output or. All right. So now let's start. This is very simple. Is one-to-one mapping. Okay. So from plain text or sequence of zeros and ones, which are changed to zeros and one, is encrypted. It changes shape to ciphertext, which is another sequence of zeros and ones. And there is a so looking at this, one cannot find out what the original message is. Okay. Okay. So if Mallory or Eve look at this, they cannot make out anything out of it because it has been encrypted using a key, using encryption algorithm, which we call. Okay, decryption is nothing but use the key to open this lock and get the plain text. So the same key is used for encryption and decryption. if we are using symmetric key encryption. Okay. All right. Okay, so what we achieve here is confidentiality. Other things we to achieve is integrity and authenticity. All right. Please go through this code. Many people still think that protecting machine or laptop is a great way, but that's not so. And don't show your dad your encrypted card, report card. Not a good thing, because your dad happens to be like me, that give me key then. Okay. Okay, so now we are going to have two important things. First is Kirchhoff principle and second is called Shannon's maxim. Okay. Is the beauty of lock and key. The lock that you buy from market for your home is based on something, right? There's some hardware inside. Do you think the locksmith is there anything secret about it? Is it secret? There might be some secret locks created which is secret, but in general locks follow the same method of locking it, right? So internal of lock, how lock should be designed is known to every lock. Okay, so design is how do you design it? As you buy a lock, what is unique about it? Unique is only key, corresponding lock. But how do you create this lock for a particular key is known to everyone. Okay. All right. So similarly in crypto, we have encryption algorithm and decryption algorithm. Now this algo should be known to everybody. Okay, all right. All right, so same encryption decryption algorithm, but different keys. The difference is that the key is important here. Key is secret. Design of lock is public. Say for example, algorithm, symmetric key encryption is DES. Now DES algorithm is public, everyone knows it. But when you are going to use DES to encrypt some input or plain text, we call it, okay, or stream of 07, but in general in our lingo we'll use plain text. And this algo is available, it's code available. But only thing difference is that this key to text to ciphertext, okay, should be unique and should be known only to this user who is encrypted. All right. And key is nothing but random bits of a string of random bits, and key for a lock is of the same size. Or encryption, for example, DESL encryption algorithm will use keys of some size, right? So initially it was 128 bit, now we have 256 bit and 512 bit keys, right? For example, the AES uses nowadays use approximately 512 bits key, and as the key size become bigger, breaking encryption becomes more and more difficult. So it's you can choose whether you want to use, if your application doesn't require too much of 128 or 192 or 512 bits, and a large number of algorithms are available. And these, now what we are talking about, symmetric key algorithm. Similarly, asymmetric key algorithms are known. Now, obviously, question comes to your mind is, should we keep encryption algorithm confidential? or should a cyber criminal or adversary know the details of encryption algorithm? What think? Answer already we have discussed earlier. Yeah, please. Anyone? Aman Sikarwar. Are you there? Hello. Aman Sikarwar, are you sleeping? And don't say your mic doesn't work. Ayush Gaurav, are you there?
Yes, sir. No, sir. I don't think that adversary should know the details of encryption algorithm.
Okay. So now this is counterintuitive. In encryption world, the method of encrypting for encryption algorithm should be known to everyone. Because theory is that someday or other it will leak. Okay, and you cannot get a lot of ideas to it. Okay, and this is called Kirchhoff's principle. So Kirchhoff's principle says that remains secure even everything accepting the key is public knowledge. Okay, and we have studied principle for that. Security by obscurity doesn't work. Let everyone know the crypto algorithm, but design in such a way that the key is important. So all the secret then is the key. Okay. Now reason for this is algorithms are different, change and update. Once you have crypto algorithm that your machine is using, you cannot change it every time. So that's the reason same algorithm is used for a long time. The secret is harder than keeping the key secret, because key you are generating. When you want to establish a channel with other party, you are generating the key to some other person, right? So keep discarding the key after use is over. The key secret is much simpler. Okay. And it's very important, the algorithm has to be robust. Okay. And if it is not public, it is very difficult to find fault and make them robust. Now, it is very intuitive, right? But it's very powerful. That's the reason it's always said never use untrusted crypto algorithm. Okay, all right. Now, based on this, there's something called Shannon's maxim, which says the enemy knows the system. So we need to design any security system knowing that enemy has gained knowledge about the system. Okay, if you're designing, for example, a building and want to secure it, never assume that some intruder to that building will not know the layout of the building. Okay, so that cannot be your important design parameter. Okay, all right. Now, here is Alice and Bob. Alice sends a message M to Bob. Okay. What if Bob says that you have not, or Bob says that, instead of sending say $100 to me, promising to pay $100 to me, you have promised to pay me $1,000. So crypto system will fail if either Alice or Bob are cheats. Okay, then it will not work, because Alice and Bob have the same capabilities and they possess the same key. Okay. Now we are talking about symmetric key encryption, right? Okay, so symmetric key in cryptography is for application where we would like to prevent cheating either by Alice or Bob. All right, and against cheating by say Mallory. All right, so this property of course is called non-repetition, where Alice cannot. How do we achieve non-repetition property wherein Alice, she has, okay, she has sent say demand. She cannot deny that at later point. And if somebody goes to Bob goes to code, she will be able to prove that I've sent this message. Okay. So now we come to types of cryptography. That, as we already discussed, there are two types of cryptography: symmetric key cryptography and asymmetric key cryptography. In symmetric key cryptography, we use just one key. This is encryption algorithm, this decryption algorithm, this is input, this is actual output. Now this is a message M, which is using the key K, is converted into message say M dash. M dash is input to decryption algorithm, and this decryption algorithm using the same key K, what we examine. Okay. Okay. So this reason sometimes we call it private encryption, but in general we will use the term symmetric key encryption. Okay, asymmetric key encryption, every user is a one-to-one communication between Alice and Bob. Okay, Alice has two keys, public key. Alice will call public key her public key. Okay, and there is a private key. Okay, so public key is used for encryption, private key is used for decryption. Similarly, Bob has public and private key. Now, so when Alice wants to send some message, and he will encrypt using Bob's public key. She will, and because Bob's public key is known, she will use Bob's public key to encrypt a message and using Bob's public key, using key of Bob. And when this is received by Bob, Bob will use own private key to decrypt the message. We'll read this in more detail as we go through. So first we'll cover asymmetric encryption, asymmetric cryptography. Okay, it goes like this. Okay, so we have encryption algorithm, we have decryption algorithm. We have Alice here, which is encrypting a message or plain text, which is sequence of zeros and ones, which let plain text here, uses a key, and it goes over as a encryption. Output is ciphertext that goes over insecure channel, is received by Bob's machine, where decryption algorithm is applied to receive message using the key. Key point here is that both keys are the same, and what Bob receives is the same plain text which Alice has sent. Okay. All right, so this is important. So terminology, we have plain text, which is nothing but sequence of zeros and ones, which is, but we'll use now only plain text for sequence of zeros and ones. Ciphertext, the output of that. After using a key, we are going to encrypt, and we are using encryption algorithm. We are for key space. How many combination of key you can generate. That's called key space. Similarly, we will have decryption algorithm. Okay, all right. So these are terms. Now the question that is to be asked is that, okay, Alice has generated key, and the same key is used for decryption. And Bob, how is he sending this message, this key to Bob? Because initially when she is sending this key, the channel is insecure. The whole objective of the question that you can ask is how to distribute key, what is the key strength, and what is the lifetime of the key, how long she can use the key once she has generated it. Okay, we will answer this question sooner or later. Okay. So this question comes again, how to change the key, and how many keys you need for pairwise communication in large group. Now we are assuming only 2%, right? In a group, you know, like your department, there can be 100 of people. Now note that this is one-to-one communication. A pair of keys have to exchange between A, B, and then A to D and whatever, right? And similarly, so all these people have communication with each other, and there are n people, for example. Then you need order n square keys. Is it right? I hope you understand the order notation, right? Okay. The question to share keys securely. Okay. And if the number of keys are very large, how do you achieve this then in distribution key? In fact, you know, about 30-40 years back, you know, Department of Defense has to send the keys to soldiers in different cities. There used to be, it used to go in an envelope personally handed over to other person. There were truckloads of key that will go from one physical location to another physical location, and they will distribute the key that way. But now on internet, how can we achieve this distribution key? That's the question. All right. Then question is that once Alice has generated the key, how is going to she store it securely? If we already, then once key is used, then we have to destruct, we have to click the key, or we have to delete the key, whatever, right? And poor key management can cause security breaches. In the while key is being about the keys, then the security breach. So in insecure channel, when we are exchanging the key, keys are exchanged securely over unreliable, unsecure channel. Okay, all right. So that's all about today. So what we have today studied is cryptography, something about cryptography, and we try to achieve CIA, confidential integrity, authenticity. It is the basis of any security mechanism. I would say most security mechanism, if not all, most. But of course, it's not sufficient for all security problems. Then another learning is that from Kirchhoff principle is never develop your own crypto algorithm unless you have world-class expertise. Okay, breaking crypto is difficult for a proven crypto algorithm. If crypto algorithm is very robust and known to be good, then keys, then it is very hard. It's impossible. Like it will take say millions of years to break it. On with the fastest computer. Okay, symmetric key encryption is very popular due to its simplicity and high speed. Use the same key here in both places. All right. However, then there are problem of key distribution. key distinction and key secrecy. Okay, got it? Any question? No? All right then, thank you.